That is, a polynomial containing any two terms is called binomial. So in each term, when you add the power of x as well as a, that should be equal to the index of x plus a. All the coefficients in the Pascal triangle is replaced by NCAR formula. When you have x plus a whole power 4, then you should write the coefficients from 4C0 to 4C1. Hello everyone, a warm welcome to one and all. This is your Shruti ma'am lecturing in Vidhyaashram, the Temple of Excellence, Mysore. So welcome to the new session of Binomial Theorem. Today we will be starting with Binomial Theorem. So let us learn what are the things we will be learning in this session. So first I'll introduce to binomial expansion. So what do you mean by binomial expansion? You know the term binomial. That is, a polynomial containing any two terms is called binomial. For example, I'll write it as x plus y. So x plus y is an example for binomial. What is this expansion? So when you have some power for this binomial, any integral power for binomial, then the expansion of those binomial term with its index or power is nothing but binomial expansion. So next we will see about Pascal triangle. So what is Pascal triangle? Next, binomial theorem. Here I have written without proof. Why? Because only the statement is there for your syllabus, not the proof. Next, we will be dealing the problems using binomial theorem. Let us have a look for a positive integral indices of x plus a. So indices means power. That is any integral power. So here I have given positive. Okay, so here is a binomial term given which is x plus a. So we are going to find the expansion of binomial with its power n. So power is nothing but index or indices. So here I am considering only the positive integral. So positive integral means here value of n should be in the set of natural numbers. So before going to the binomial expansion, let me study. Whenever you have a power 0, 1, 2, 3, 4, what happens to the binomial expansion? So you can clearly say here x plus a whole power 0 is 1. Why? We know in the laws of indices, anything to the power 0 is always 1. Anything to the power 0 is always 1. So therefore, x plus a whole power 0 is always 1. But remember, the term x plus a is not equal to 0. Only when its power is 0. When the power of x plus a is 0, it is equal to 1, but not x plus a. So x plus a is not equal to 0. Suppose you have power 1. What does it mean? You have to multiply the given term one time. So therefore, x plus a one times become x and a. So x plus a whole square you have. You can use the formula of a plus b whole square. So it indicates the following terms: x square plus 2xa plus a square. Similarly, x plus a whole cube you have. So you have x cube plus 3x square a plus 3xa square plus a cube. That is, here you can use the formula of a plus b whole square. Here you can use the formula of a plus b whole cube, which you have learnt in your secondary classes. Now you have x plus a whole power 4. So how you can write x plus a whole power 4? X plus a whole cube into x plus a. Already you know x plus a whole cube. Just multiply one more x plus a, then it becomes x plus a whole power 4. So after multiplying each term here, look here, I'll explain. We have x plus a whole cube into x plus a. So this is equal to x plus a whole power 4. So we know x plus a whole cube is x cube plus 3x square a plus 3xa square plus a cube into x plus a. Using binomial product, just multiply with x one times, then multiply with a. What happens when you multiply x here? X into x cube, x power 4, 3x cube a plus 3x square a square plus xa cube. Then multiply with a. So this becomes ax cube plus 3x square a square plus 3x a cube plus a power 4. So this is equal to x power 4. You have x cube a. So therefore it is 4x cube a plus you have x square a square. So 3 plus 3 is 6x square a square plus again you have ax cube. So 4x a cube plus a power 4. So this is what the expansion we got here. So like this, we have to go on multiplying for the integral powers of x plus a. So one more thing you have to find out here is when you have higher number of powers. For example, n is equal to 20, n is equal to 100. So you cannot go on multiplying x plus a each times and find the number of terms in the binomial. So for this thing, the binomial theorem statement is very important. But before going to binomial theorem, so let us see some observation in the expansion of this x plus a. See here, when you have n as an indices, you have n plus 1 terms. That is, here you have the indices as 0. So here number of terms is 1. Here you have the index as 1. So therefore number of terms is 1 plus 1, which is equal to 2. Here you have 2. So therefore here you have 3 terms. And here you have 3. So here you have 4 terms. Similarly, here it is 4. You have 5 terms. So what does it mean? The very first observation here is the total number of terms in the expansion is 1 more than the index. That means when the power of x plus a is n, then number of terms in the expansion will be n plus 1. So that is 1 more than the index. For example, in x plus a whole cube, the power was 3, but number of terms was 4. So you can see here, the index was 3. Number of terms is 1, 2, 3, 4. So 4 terms. So that is what my first statement. So what about the second statement? The power of x go on decreasing, and whereas powers of a go on increasing. So we will see how it works. See here, you can see the expansion of x plus a whole power 4. So this is x plus a whole power 4. So power 4 means you will be having 5 terms. 1, 2, 3, 4, 5 terms. Look here, the power of x in each term. So this is the highest power of x. After it is cube, then square, then 1, then nothing is there means the power of x is 0. So here we can see the power of x is 0. Since x power 0 is 1, no need to mention it here. That is why there is only constant there. So what happens here? The power of x go on decreasing from 4, 3, 2, 1, 0. What about a here? In the first term, a is absent. That means the power of a is 0. In the second term, it is 1. In third term, it is 2. In fourth term, it is 3. And in fifth term, it is 4. So what is this? So you can see that the power of x goes on decreasing from the highest power to 0, whereas the power of a goes on increasing from 0 to the highest power. So this is what the statement says. And one more observation is, in each, the sum of indices of x and a is same as x plus a. So when you add the power of x as well as a in each term, then that should be equal to the power of the x plus a. I'll explain with x plus a whole cube. So what does it means? So it is x cube plus 3x square a plus 3x a square plus a cube. So this is what the expansion or cubic expansion of x plus a whole cube. So according to the first point, if index is 3, the number of terms should be 4. 1, 2, 3, 4. So correct. Next, second statement, power of x must be decreasing. So you can see here it is 3, 2, 1 and 0. And power of a goes on increasing. Here it is 0, 1, 2, 3. Whenever you have a power as 0, no need to mention there. So because its value is 1. So 1 into anything is the same. So therefore here x cube and here a cube. What does my third statement says? That is in each term. When you add the total power of x as well as a, it should be equal to the index. Look at the first term, here it is 3. Look at the second term, x square a1. So 2 plus 1 is 3. So this is equal to 3. Similarly, here it is 1. 1 plus 2 here, it is equal to 3. And similarly, this is equal to 3. So in each term, when you add the power of x as well as a, that should be equal to the index of x plus a. Next, Pascal triangle. A very important concept while using the binomial expansion. Why? What is Pascal triangle? So this was designed by a mathematician called Pascal. So since it is in the triangular form, it is called as Pascal triangle. So how it works? So just see how it came. Here is my first 3 terms. So next, like this, 1 plus 1, 2. Next, 1 plus 2, 3, 2 plus 1, 3 and 1, 1. Like this, you should go on writing 1, 1 before the coefficients here. Then add 1 plus 3, 4, 3 plus 3, 6, 3 plus 1, 4. Again 1, 1. 1 plus 4, 5, 4 plus 6, 10, 6 plus 4, 10, 4 plus 1, 5. Again 1, 1. 1 plus 5, 6. Here it is 15. Here it is 20. Here it is 15. Here it is 6. Again 1 and 1. So this is what Pascal triangle. You can go on trying. It is an infinite numbers you will get. So here I have given index and here I have given coefficient. What does it mean? So index here represents the power of x plus a. So if the power of x plus a is 0, then you have only one term and here this is the answer 1. This represents the coefficient. If the power of index is 1, that is x plus a is 1, then you have a coefficient for each term 1 plus 1 and here it is x and here it is a. So since 1 is not written specifically because when you multiply you will get the same answer or same value. Next, coming across here, what is this? If the index is 2, what happens if the index is 2? X plus a whole square. Your coefficients will be 1 plus 2 plus 1. So, x square, x and here it is a square. So, like this the coefficients will be, and for x cube, so x cube, what are the coefficients? 1, 3, 3, 1. So look here, it is 1, 3, 3, 1. So this represents the coefficients in the binomial expansion. So the values in the Pascal triangle represents the coefficients in the binomial expansion. And using the concepts of these points, we can directly write the expansion without multiplying. So let us see how we can write. I'll take an example of x plus a whole power 5. So I'm taking an example of x plus a whole power 5. What must be the coefficient and how I can write easily without multiplying the terms x plus a. So if it is x plus a whole power 5, how many terms it should contain? It should contain 6 terms. So the first point says if you have 2 as an index, you will be having 3 terms. If you have 5 as an index, you will be having 6 terms. So therefore, there will be 6 coefficients. So what are the coefficients? Just look at the Pascal triangle. So when you have power as 5. The coefficients will be 1 plus 5 plus 10 plus 10 plus 5 plus 1. How can I write the power of x and power of a? So use second point. What does the second point says? Power of x goes on decreasing and power of a goes on increasing. So remember that in the first power it is x power 5. So a is absent in the first term and x is absent in the last term. So go on decreasing the power of x. So this is x power 4, x cube, x square, x. No need to, this is nothing but x power 1. Here I have to write x power 0, but no need to mention. Next here, go on increasing the power of a. So we should start with a power 0. No need to write. If you want, you can write. So a power 0, a power 1, a power 2, a power 3, a power 4, a power 5. So since anything to power 0 is equal to 1. So what happens for this expansion? This is x power 5, 5x power 4a plus 10x cube a square plus 10x square a cube plus 5x a power 4 plus a power 5. So this is how I can write any binomial expansion using Pascal triangle, where you will get the coefficient for the index, for the particular index of a binomial, and using the concept of x decreasing from the first term to last term and a increasing from first term to last term, we can write the expansion of binomial theorem of any power, So I'll take one more example now. Expand 2x plus 3y whole power 5. So you should remember the coefficient of power 5 in the Pascal triangle. So what are the coefficients of power 5? 1, 5, 10, 10, 5, 1. So you should write it separately. So how? I'll just explain. So write 1 plus 5 plus 10 plus 10 plus 5 plus 1. So what are the things? So what is given in the data here? Here the value of x is replaced by 2x, value of a is replaced by 3y, and n is here 5. So what is my first number of terms? Should be equal to 5 plus 1, which is equal to 6. You can see since you have 6 coefficients, that is nothing but you will be having 6 terms. So what is my first point? I have to write the coefficients in the Pascal triangle for index 5. Next, write the power of x in the decreasing order. So therefore, I am writing it. So here I have 2x power 5, 2x power 4, 2x power cube, 2x square, 2x 1, so 2x 0. Next, write the value of a in the increasing order of its power. So that is 3y whole power 0, 3y whole power 1, 3y whole power 2, 3y whole power 3, 3y whole power 4, 3y whole power 5. So this is what I get. The same thing. This is what I get. So after multiplying the values of constant and writing the powers of x as well as y, you will get the answer that like this. So the expansion of 2x plus 3y whole power 5 is 32x power 5, 240x power 4y, 720x cube y cube, 810 x y power 4, 243 y power 5. So how did you got? So by expanding the powers of 2 and 3 and then multiplying all the constant. So I hope you understood how we can write the expansion of any binomial term when index is known. The thing is, you should remember the coefficient and the idea of x decreasing and a increasing. Well, this have a limitation. Why it has a limitation? We cannot remember all the coefficient when we have higher powers. For example, you have 10. Then you will be having n plus 1 terms, 11 terms. So you should remember the coefficients of all the 11 terms. It is very easy to write x in the decreasing order and a in the increasing order. But to remember the coefficients is quite difficult. That is why the coefficients in the Pascal triangle is replaced by the formula. What is that formula? We'll look now. So this is the formula. How combination formula? Why combination formula is used instead of coefficients in the Pascal triangle? We will see now. So we have a Pascal triangle like this. So what does 1 means in combination formula? So here it's what? NC0, NCN is nothing but 1. So wherever you have n, so this is nothing but NC0 here. And this is NCN. Here it is NC0, NCN. So similarly, if you go on writing like this, so here it is again NC0 and here it is NCN. Because the first term is considered as NC0 and the last term is considered it as NCN. So remember all the coefficients in the binomial expansion. The first and last term have the coefficients 1, where the first term is replaced by NC0 and the last term is replaced by NCN, which is nothing but 1. Which is nothing but 1. So how we will get these 2, 3, 3 like this? That depends on the terms, the index. For example, so here this is nothing but 2C1. So 2C1. Here it is nothing but 3C1, 3C1. So when you go on, so here I can just replace. So this is for index 1. This is for index 1. I'll write here again. So you have 1, 1, 1, 1, 2, 1, 1, 3, 3, 1. Just add it. The first triangle is 1, 1, 1. Then go on adding with the corresponding values. So it is 1 again, 4, 6, and here it is 4, 1. So now, since this is for the index 0, this is for the index 0. So this can be considered as what? 0C0. Okay. So this can be index as 1. So that is nothing but here it is 1C0 and here it is 1C1, which is nothing but 1 and 1. Remember x plus a whole power 1 expansion. This is for the index 2. So therefore this is 2C0, 2C1, 2C2. 2C1, remember the formula, that is NC1 is always n. And NCN minus 1 is always 1. Okay. So now this is for the index 3. So this is nothing but 3C0, 3C1, 3C2 and this is 3C3. So 3C1 is like NC1. 3C2 is like NCN minus 1, which is n only. Again here this is for index 4. So therefore it is 4C0, 4C1, 4C2, 4C3 and 4C4. So like this you can write all the indexes in combination formula. So that is why all the coefficients in the Pascal triangle is replaced by NCAR formula, which will give you the coefficients of binomial expansion. So that is what the statement of binomial theorem states. So let us look what this binomial theorem states. So the theorem for positive integral power. So as I already said, here we are going to find the expansion of binomial where the power n is always positive. So what is the expansion when you have n number of terms? So as I said previously, when you have 3, it is 3C0, 3C1, 3C2, 3C3. That is the last term. So when you have power n, then it should be NC0, NC1, NC2 and NCN in the last term. And use the knowledge of decreasing powers of x. X power n, x power n minus 1, x power n minus 2 and here it is x power 0, but no need to write x power 0. And again increasing powers of a. So first is a power 0, no need to write. Second is a power 1, a power 2. At last it is a power n. So remember the statement of binomial expansion. So very easy to remember. So since the concept of all coefficient is replaced by the combination formula. So when you have n number of terms, then the coefficient can be written from NC0 to NCn and x in decreasing order, a in increasing order. So only the statement is very important to calculate the problems, but proof is not necessary since it is not in your syllabus. We'll take some problems so that we can work out using binomial theorem. First problem, expand 3x plus 2y whole power 4. So what is there in the place of x? 3x. What is there in the place of a? It is 2y. What is my n? It is 4. So when you have x plus a whole power 4, then you should write the coefficients from 4c0 to 4c1. Let me write it using the statement of binomial theorem. Here I have 3x plus 2y whole power 4. So let me write the coefficients from nc0, nc1, nc2, nc3, nc4. So since my n is 4 here, just replace all the n by 4. So this is how it looks. So when you have power 4 as an index, then it is from 4c0, 4c1, 4c2, 4c3, 4c4. So next I have to write the value of x in the decreasing order. So 3x whole power 4, 3x whole power 3, 3x whole power square, 3x power 1. And no need to write the last term. Next we have a. We should write a in the increasing order. So in the first term, a is power 0, so no need to write. So in the second term, it is 2y power 1, 2y power 2, 2y power 3, and this is 2y power 4. So this is how the expansion looks using binomial theorem. So write all the coefficient in the NCR formula, decrease the power of x and increase the power of a. So now we'll evaluate it. So before that, you should know some properties of combination, that is NC0 and NCn is always 1. Whenever you find these type of combination, the value is always 1. Similarly, NC1 and NCn minus 1 is always n. For example, I'll write using here only. Here 4c1, 4c3 will be equal to 4. And 4c0, 4c4 will be equal to 1. And the rest of the thing we have to calculate. So now I'll just replace 4c4. So what is 4c0? It is 1. So no need to write since it is 1. Next we have 3 power 4. So 3 power 4, x power 4. Next, what is the coefficient of 4c1? It is 4. Next we have 3 cube, x cube and into 2y. Again, we have 4c2. How to calculate 4c2? Using combination formula. So 4c2 is nothing but select two terms, 4 into 3 divided by 2. That is equal to 6. So therefore 6, and there it is 3 square x square into 2y whole square, 2 square y square. Next is 4c3. I have already done 4c3 is 4. So 4, 3x and here it's 2 cube y cube. And the last coefficient is 1. It is 2 power 4 y power 4. So this is how the expansion looks like. Then find the values of all the numbers there and multiply them. You will get the final answer. So here is what I'll get. That is 81 x power 4 plus 216 x cube y plus 216 x square y square plus 96 x y cube plus 16 y power 4. So this is the expansion of 3x plus 2y whole power 4. We'll take the next problem. Expand 3x plus 1 by x whole power 5. So just first write the coefficients in the combination NCR form. So that is 5c0 plus 5c1 plus 5c2 plus 5c3 plus 5c4 plus 5c5. The last term ends with NCN. Next, this is x. X is 3x here. A is 1 by x here. And n is equal to 5. So when you have n is equal to 5, the number of terms is 6. We can clearly see 1, 2, 3, 4, 5, 6. Now, decreasing order of power x. So 3x whole power 5, 3x whole power 4, 3x whole power cube, 3x whole power square, 3x whole power 1, 3x whole power 0. No need to write. Increasing order of a. So 1 by x whole power 0. No need to write. 1 by x whole power 1. 1 by x whole power 2, 1 by x whole power 3, 1 by x whole power 4, 1 by x whole power 5. Also remember the thing that when you add the powers in each term, that should be equal to 5. Look here, it is 5, 4 plus 1, 5, 3 plus 2, 5, 2 plus 3, 5, 1 plus 4, 5 and 5. In each term, the sum of the powers of x and a must be equal to the index. Now, we'll solve it. So, using the properties of combination, 5c0 or 5c5 is nothing but 1. Again, 5c1 and 5c4 is nothing but 5. So, what I am left with 5c2 and 5c3. I'll say this is equal. Both are equal. If you find the value of one thing, you can find the other. Why it is equal? Because you can see here n is equal to 2 plus 3. You come across the property in the combination that if NCA is equal to NCB, then n is equal to a plus b. So here I am getting n is equal to a plus b. So therefore, both the combination N5C2 and 5C3 will have the same value. So I'll just find the value of 5C2. What is 5C2? Select two terms, 5, 4, divide by 2 terms, 2 into 1. So it is 20 by 2, which is 10. So these two are equal to 10. Now just replace the coefficient and multiply the powers and multiply the variables. So what I'll get here? So 5c0 is 1, no need to write. So this is 3 power 5, x power 5 plus 5c1 is 5. And here it is 3 power 4, x power 4. And 1 by x can be written as 1 by x only since its power is 1. Next 5c2 is 10, 3x whole cube we have 3 cube, x cube. Next 1 by x whole square we have, so it is 1 square 1 and here it is x square. Next we have 5c3 which is same 10, 3 square, x square and here it is 1 by x cube. 5c4 is 5, 3x, 1 by x power 4 and finally, so coefficient is 1 and here it is 1 by x power 5. Cancel the term here, x, x power 4, x square, x cube and x square cancel, 1x remains in the denominator, x cancels, x cube remains in the denominator. So just write the value. So what is 3 power 5? So after multiplying here the value of each term along with 5, 10 outside the brackets. So we will get 243 x power 5 plus. So 3 power 4 is 81. 81 into 5 is 405. X cube is remaining there. Next, 10, 3 cube is 27 into 10, 270. So x square cancels, so remaining is x. Then here we are left with 3 square 9, 9 tens are 90, and in the denominator you have x. Then again you have 15, and in the denominator you have x cube. Finally, we have 1 by x power 5. So this is the expansion of 3x plus 1 by x whole power 5. We'll take one more problem. Expand root x minus 1 by root x whole power 6. So remember this, 6c0, 6c6 is 1. 6c1, 6c5 is 6. And along with this, what are the things we have to find? We have to find 6c2, 6c3, 6c4. 6c4. So see here, 6c2 and 6c4 values will be same because when you add 2 and 4, you will get 6. So just find the value of 6c2. The value of 6c4 is same. So what is 6c2 will find? Select only two terms. 6 into 5 divided by 2 factorial, that is 2. So 30 by 2, it is 15. So 6c4 is also 15. So we will find the value of 6c3. So this is equal to 6 into 5 into 4 divided by 3 factorial, which is nothing but 3 into 2 into 1, which is same as 3 into 2. So it is 120 divided by 6, that is equal to 20. So I am just replacing the coefficients directly there. So we know it is 6c0 root x whole power 6. Next, 6c1 root x whole power 5. But remember the value of a is here minus 1 by root x. In the expansion, you will be having positive, but when you have minus, you should replace a by minus only. So this is minus 1 by root x. Next, you have 6c2 root x whole power 4 minus 1 by root x whole power square plus 6c3 root x whole cube minus 1 by root x whole cube plus 6c4 root x whole square minus 1 by root x whole power 4. Next we have 6c5 root x whole power 1 minus 1 by root x whole power 5. Finally, 6c5 minus 1 by root x whole power 6. So just replace the coefficients what I have got. But remember here root x and 1 root x cancel. Here also root x square cancels with root x square. Root x whole cube cancels. Here root x square cancels with power for the denominator, and here root x cancels with power of the denominator, and here nothing to cancel. So what is this root x? Root x is nothing but x to the power 1 by 2. So when you have root x whole power 6, that means what? 1 by 2 whole power 6, which is nothing but x power 6 by 2, which is nothing but x cube. So using the concept for all the terms, what I'll get here is, so you have root x cube, so you have root x whole power 6, x cube we will get. So here you have minus, so therefore here minus root x whole power 4, that is nothing but x square, but 6x square, coefficient of 6x1. Next, 6c2 is nothing but 15. And here you have root x square cancel. So root x whole square is only x. Next here, both are cancelled, but you have minus. When you have odd powers, that is nothing but minus. So 20. Next you have root x square. Root x square in the denominator is cancelled. Since it is square, the value is positive. So it is 15 by x. And similarly, you will be having minus 6 by x square. And finally, you are left with 1 by x cube. Because you have power 6. So root x whole power 6 is nothing but root x power 6 is nothing but x cube. So, but in the denominator you have, and the coefficient is here, 6 is 6. So it is 1. So this is the final answer I'll get for this expansion. Moving on to the next question. We have here the combination of two binomial terms. So let us solve them separately and use the concept of subtraction by changing the sign. So let me expand 3 plus 2 whole power 6. Here 3 plus root 2 whole power 6. 3 minus root 2 whole power 6. So but when you have minus, change the sign alternatively. Plus minus, plus minus, plus minus, plus minus. And when you have plus, all the terms are positive. So before going, since it is 6, so we have previously learned the values for 6C0, 6C1, 6C2, 6C3. I'll just write it here again. So 6C0, 6C6 is 1. 6C1, 6C5 is 6. 6C2 and 6C4 is 15. 6C3 is 20. So these are the values I got. I'll write that directly. So here I got 6C0, 3 power 6 plus 6C1, 3 power 5 root 2. 6C2, 3 power 4 root 2 whole 6 whole square. Next 6C3, 3 cube root 2 whole cube. Next 6C4, 3 square root 2 whole power 4. 6C5, 3 root 2 whole power 5. Finally, 6C6, 3 is absent, root 2 whole power 6. Similarly, expand this one. So you will get the same but change the alternative signs. Minus 6C1, 3 power 5 root 2. Plus 6C2, 3 power 4 root 2 whole square. So this is minus 6C3, 3 cube root 2 whole cube. Next 6C4, 3 square root 2 whole power 4 minus 6C5, 3 root 2 whole power 5 plus 6C6 root 2 whole power 6. So what I should do here, I should subtract. So when you are subtracting, you can change the sign of the second expansion. So here you have positive, make it negative, positive, negative, positive, negative, positive, negative. So when you have alternate signs for the same value, you can cancel it. For example, plus 2 minus 2 get cancels. In the similar way, these two get cancels here and these two terms, and finally these two terms. So now we are left with, so this I can write like this. So 3 plus root 2 whole power 6 minus 3 minus root 2 whole power 6. So this is equal to, how many times I have 6C1? 2 times. How many times I have 6C3? Here I have changed the sign. So remember, they are not plus and minus. They both are positive. 6C3 plus 6C3, 2 6C3. Similarly, 6C5 plus 6C5, 2 6C5. So each time I am getting twice. So I will take 2 as a common factor. So when you take 2 as a common factor, you have 6C1, 3 power 5 root 2. Again, plus 6c3, 3 cube, root 2 whole cube. Next, we have 6c5, 3 root 2 whole power 5. So now, just replace the coefficients 6c1, 6c3, 6c5 with the values given here. So when you have replaced, then 3 power 5, that is 3 cube and 3 we have. So root 2, here also root 2 we have, here also root 2 we have. You can take root 2 as a common factor, or you can write root 2 cube. So root 2 cube can be written as 2 root 2. And root 2 whole power 5 can be written as 4 root 2. So use these values inside the brackets, and finally you will get the value as 5220 root 2. So this is what the expansion of this term is. Next question. 1 plus root 5, 1 minus root 5 I have. So before going to 5, just find out the coefficients. Since n is 5, we have 5c0 and 5c5. We have 5c1 and 5c4 and 5c2. So last expansion, 5. So 5c2, how much you will get? 10. Remember these values. Let me expand 1 plus root 5 whole power 5. So instead of writing the coefficients in NCR form, I'll just write 1, 5, 10. I'll replace with 1, 5, 10. So 1 into, first term is 1 power 5. So 1 power anything is always 1. So I'll not represent 1 anywhere. I'll just write the powers of root 5. So root 5 is absent in the second term. So for 5c0 I have replaced with 1. Next I'll come with 5c1. 5c1 is nothing but 5. So 1 power 4 it becomes, which is 1. Root 5 must be written. Next I have 5c2. 5c2 is same, that is 10. And 5c3 is also 10. Because 2 plus 3 is 5. So next I have to increase the power of second term. Next again 5c3, 10 root 5 whole cube. Then I'll get 5 root 5 whole power 4. Then I'll get 1 again. It is root 5 whole power 5. So now change the alternate signs for 1 minus root 5, which is same here 1 and here minus 5 root 5. Here it is plus 10 root 5 whole square minus 10 root 5 whole cube plus 5 root 5 whole power 4 plus root 5 whole power 5. Change the alternatives sign. Make it as minus, plus, minus, plus, minus, and here it is plus. So cancel the sign. So this is nothing but 1 plus root 5 whole power 5 minus 1 minus root 5 whole power 5. So first term, third term and fifth term get cancels. So all the terms we have twice. So I can take 2 as a common factor. 5 root 5. Root 5 cube. So root 5 cube is nothing but root 5 whole square into root 5. So root 5 square get cancelled. This can be written as 5 root 5. So I'll write this as plus 10 into 5 root 5. Similarly, root power 5 whole 5. So root 5 whole power 5 can be written as root 5 whole square, root 5 whole square into root 5. So this is nothing but 5 into root 5, which is 25 root 5. So therefore, I'll write this as 25 root 5. Again, you can take root 5 as a common factor. So you are left with 5, 10 5s are 15, 25. So finally, you will get the answer as 160 root 5. So this is how we will solve the solutions using the binomial theorem. So I hope you understood all the concepts of writing the binomial statement and expansions of binomial terms whenever the values are given. So in today's session, we learned how we will write the statement of any binomial expansion when it has n as an index. And also, you should remember 3 points. If you have n as an index, you will be having n plus 1 terms. For example, if you have 4 as an index, the expansion contains 5 terms. Also, the power of x will be decreasing and the power of a is increasing. So remember these 3 concepts to write the expansion of any binomial term. So in the next class, we will take a few more problems and some more points in the binomial theorem. So till then, keep watching, keep learning and keep exploring. Thank you.